as the interpreter. Okay, so ladies and gentlemen, we're going to be conducting this work within the context of Zeppelin. Okay, so if you haven't done so, you're going to want to create a new note and use the default interpreter of Spark. That's how I got to this place here. Okay, and we're going to use this session to explore 3 types of collections provided by Spark. I noted that all of these collections share these basic features. They remember their lineage, they're fault tolerant, they're memory conserving, they're lazy, they can target multiple machines, and they're interoperable with classic types within Scala. But these types of collections have different interfaces to the user, and they in fact have different trade-offs associated with them. As we'll see, the first generation of datasets is kind of a lower level interface. It's very powerful, but it requires more detail in terms of specification, and it's in terms of performing actions, and it can be more cumbersome in some cases. And it lacks some optimizations afforded by later ones, okay? So the first generation is resilient distributed datasets, and really it's the foundation which the later ones built. The next generation is something called Dataframes, previously called schema RDDs. And these Dataframes build on similar abstractions you'll find in many platforms. In Python, in as much as it's being used for data science. Also in R, where we use Dataframes centrally. Many of you have experienced them. So Dataframes differ from datasets, and we have these named columns that are columns of data. It's really for tabular data. We're conscious of this schema, and we can optimize querying, data movement, and memory management within the context of the schema. This says schema known statically, but there's a lack of type safety using fields. As we're going to see, the user mentions the names of the fields they want to use, but it can't check statically. It can't check in a compiled way whether this is a legitimate name. It has to wait until it executes it to see, is this legitimate, okay? And this leads to loss of type safety, okay? It has some optimizations that make it particularly attractive and a flexibility that's very attractive, but it has a lack of type safety, which is disconcerting. And partly because of those shortages, Spark rolled out a 3rd generation, which actually now Dataframes draw on as kind of a generalization of it, which are datasets. These are type-safe collections that have many of the best features of Dataframes, but at the same time, they've even more optimization. I mean, after all, we know the types involved now. And you have type safety in terms of many types of operations. Not all, but many types. And we can convert these to datasets or to RDDs, and there can be extra levels of query optimization and memory management compared to what's possible with RDDs, okay? Now, all 3 of these types of collections coexist and can be readily used with conversions between them. So we're going to walk through, in this session, we're going to walk through use of each of these 3 types of mechanisms. And we're going to see side by side, as it were, how they compare with some similar tasks, okay? And in order to do that, we are going to make use of this Spark interpreter, okay? So within Spark and Zeppelin, we're going to be provided with an interface that allows us to interactively issue Spark commands, much as in Scala shell, we're able to interactively issue Spark commands. Now, one thing you should realize is that Spark can be used in an interactive way, like we'll be using. Very powerful, and it's optimized to allow that interactive data analysis in a performant way. But as we'll see later in class, it can also be used from a self-contained compiled project built with SBT and turned into a project where it uses Spark almost as a collection of libraries or framework which it's using. Here we're going to be doing it interactively. And because it's interactive, there are certain things that we need actually to define within a compiled set of code using SBT, for example, whereas here they're predefined, okay? So there's certain types of built-in constructs that are provided to us by virtue of Spark. So one of them is something called SC, the Spark context, okay? There's another one which is called SQL context. And different versions of Spark have actually required this to be obtained from SC, but these are two built-in mechanisms in Spark. And here we're using Spark 2.2.0, I think, where these are just readily available, okay? And you want to use them early, and you want to use them often, and you want to remember that they're around because we're going to use them for a lot of our needs, okay? So when we go and we do things that tap the abilities of Spark, we're also often use SC and SQL context, okay? Okay, now I want to give you a somewhat gentle introduction to this. So I'm going to be weaving in some elements that are familiar from our work with Scala with new things in Spark, because I want you to kind of feel you're in a somewhat familiar environment so you can appreciate the new things being added in rather than just throwing you into the ocean of Spark and having you struggle, okay? So I'm going to introduce some things which should be points of reference. And one of them is going to be a construct that's very useful in Spark. It's a case class. Does anyone remember case classes? That many.
It automatically defines getters and
yeah, exactly. We covered it a number of lectures ago. It's a case class is a Scala class, but it has extra things that it provides. It has getters and setters, provides a lot of default methods. By default, it's read-only, actually. But more than this, it defines a companion class, which knows how to construct it, knows how to take it apart. So we could just say, instead of new person, as we would with a normal class called person, we can say person with these attributes. So let's create a case class, okay? Here's our case class. You may remember several times ago, we actually created a case class, and then I used Java P to dump its characteristics, and we saw what was in it, like what things were defined automatically. So I'm going to create a case class. It's going to consist of a name, a sex, an age, and an income. Are we ready for that? Well, ready or not, here we come. Okay. Okay. Here's a person. Okay. Do you see that? Okay. Now, case classes are important in Scala. Case classes are important in Spark because case classes, amongst other things in Spark, provide you a way of specifying the schema, what information is available associated, say, with a data frame to render it into a data set. As we'll see, there's some ways we can infer that cleverly by telling Spark, but case classes are one of the main ways we basically tell Spark, hey, I'm dealing with a data frame or an RDD or a data set that has this schema, okay? And when we're going to a type-safe mechanism, like with RDDs and with data sets, that's really important. So that it knows, oh, what are the fields here, okay? But let's go create a manual collection. We're going to read it from a file soon, but let's create a manual collection, okay? So I'm going to create a person here, okay? And I'm going to say val p1 equals person. Here we go. Person. This person's name is going to be NDO, okay? You can guess who that is. He's going to be, when he wrote this, he was 48. Now he's 49. Okay, and his income is 1.0, okay? The units of that are the Osgood. Okay. Oops. Oh, BSL. Oh, I said that should have been Val. Sorry, not BSL. BSL. Okay. Okay. So here's a person, right? I've just constructed a person. I didn't have to say new person, although I could have done that with a classic case. But because I have a case class as a companion object that knows how to build objects like that. But more than that, because I have a companion class, you may remember I can deconstruct objects, destruct them. I could take them apart. So I can say, for example, val person, name, sex, age, income equal to P1. And what will this do? What does that do? It looks like somewhat unwieldy syntax, but who could say what that does? Oops. Mumble. Okay. Okay. Now, why is that not working?
Call it P2.
Oh, did I call it P2? Thank you. Okay. Okay. Not enough sleep. Okay. There we go. So what is it doing?
Taking the fields of P1.
Yeah. It's taking it apart. Just as this put these fields together to form a person, this one took apart this person into their constituent components. Do you see that? So now we can refer, for example, to age. And what will it give? Something that sounds incredibly old to you. I know, 49. Believe me, it's not that old. Okay, take my word for it. You'll soon see. Okay, so ladies and gentlemen, let's now import scala.util.random because we don't want just one person. We want to have a set of people. Okay, and we're going to create a population. This is all old hat for you, right? I mean, this is pretty familiar stuff, but soon in another line, we're going to take a right angle turn to spark greatness. Okay, unless you protest. You prefer not to engage in greatness. Okay, here we go. Val population equals, and we're going to say array.fill, 1,000 people, and we're going to give each of them a name. We're going to give each a sex, an age, and an income. Are you ready? Hearing no objections. For their name, I'm going to say next string of 3. Anyone? What does this give? Anyone? What does it say to be next string of 3?
3 random characters.
Yeah, 3 random characters. Not all necessarily in scripts familiar to you. Okay. For their sex, we're going to encode it as 0 or 1, as is the long time tendency within biostatistics, and so it's going to be 1 plus next int of 2. What does next int of 2 give? Random number between 0 and 1. Yeah, it's either 0 or 1, and we'll add 1 to it, so it's either 1 or 2 for the sex, because that's how they tend to denote it in biostats. Okay. I'm going to say next int of 100 for their age. Makes 49 not seem too old. And then I'm going to have an income. Okay, 50,000 times next double. Next double returns what? Anyone?
0 and 1.
Yeah. Note I don't even have to specify begin paren there. In fact, by Scala convention, I probably shouldn't. So what does that create? Is this all the same person repeated many times? No, because remember, this is passing a thunk of sorts. It's passing a computation to be performed, right? It's passing by what? Calling by name. It's calling it with this computation. So it's not evaluating each of these and telling it to create 1,000 people with a particular name, a particular sex. Rather, this is the formula by which it will compute each person. This is called by name. You remember that? Okay, so all this should be familiar to you. What's less familiar are these names, but you know, don't be fazed by that because the world's a big place. Okay, and after all, it is Chinese New Year. Okay, okay. Well, tomorrow is. Okay, so we've just created a population. Familiar territory, right? Let's now create a Spark construct that uses this. This is all obviously within Spark. We're all operating within the Spark shell. Things are good. Lots of familiar things here. And in fact, in the Spark shell, we use a lot of Scala mechanisms, a lot of Scala collections. Fine. But ladies and gentlemen, let's do more than that. Let's go create an RDD. I'm going to create a population RDD. This is an RDD for this population. I'm going to say SC dot parallelize population. Okay. Ladies and gentlemen, I've just created an RDD here. I've just created a data set that describes a collection that, just like this population describes a collection, but this is much more powerful because it allows the elements of that collection to be divided up in terms of computation among many machines, to be distributed over a large set of different computational units, such as the labs sitting behind you folks, right? So this is taking this population, which is a very modest size, but we could have made it 10,000, 100,000, a million in size. And we've had a name for it here, okay? Okay. Now, as it turns out, we had this materialized already, but in general, as we'll see, RDDs just remember how to compute something, a promise to compute it. Okay, but let's take this RDD and let's undertake some actions on it. Let's filter individuals according to their age, okay? I want to do filter. Well, if I were doing this on just the population, not the population RDD, what would I do to say I want to filter to only include people who are less than 25 years old? How would I do that? Tell me something I'd write in here. What does filter take as an argument? Yeah, it takes a function. It's a higher order function. It takes a function as an argument. So how would I say I want to keep things where the person is less than 25? Okay. Yeah. Okay. So we could do P colon person, right? Alternatively, what's the quick way of writing that? For many, where type inference works, we could do underscore age less than 25, right? Now, suppose we were to do that. What happens? Oh, okay. You notice it didn't do the full computation. Why not? Because it is lazy. Lazy, ladies and gentlemen. Let's take the first 5 of these. All right? Does that remind you of something? Taking these? It's a little bit like streams, remember, where we wanted the first couple? Well, that's what we're doing here. Do you see this? This should look very familiar. This is very similar to what we would do, like in terms of filtering, if we were operating off the regular population construct, right? Up here, right? And this is the first 5 of those that satisfy this predicate, right? So this should be somewhat familiar to you. You should say, oh, yeah, this is type safe. I mean, I could specify for each person in this RDD, I want those whose age is less than that, and then take the first bunch. You should be getting your sea legs here in terms of this. But let's do more than that. Ladies and gentlemen, let's do the following. Let's say we want to say val lifetime earnings. This is going to be a rather crude approximation. Lifetime earnings for pop. Okay. And we're going to say, and we can copy this. We'll do it for, we'll say lifetime earnings for young pop. Okay, young pop, the youngest people. Okay, there we go. There we go. Got map, and we're going to here say we're going to take in a person P. We're going to map for each person. We're going to take their age times their income for each of those persons who matches this predicate. Are we okay with that? Okay, watch this. Watch this. Okay, so here we have a filter, here we have a map. And what is this going to give? For each person, it's going to give their kind of lifetime earnings if they were earning that income over the entire age, right? Which children are unlikely to do. Okay, so I said filter. Okay, sorry, folks. Population RDD dot filter. Sorry, I don't know where my brain is. Okay, here we go. See that? Okay, ladies and gentlemen. So this lifetime earning for young Pop, I will tell you that has not yet been computed. Okay, it's a promise. It's waiting to be computed. It's lazy. It hasn't yet computed it. I could actually say here that, and I could say to debug string. Okay, boom. And you'll notice it tells me what I can do with that. Okay, do you see that? See with that? So it's saying, okay, look, this came from something where I parallelized something. That was, after all, right here, right? I parallelized that collection. And then I performed a filter on it, and then I performed a map on it, So here, it actually knows how to compute it. And if this were materialized, if it actually computes it, that allows it to do what? If we actually compute it, and I'll say, for example, lifetime earnings for young Pop dot take 5, it's going to need to materialize. Oops, I'm just typing things left and right. Okay, here we go. There we are. Suppose that memory were getting really tight. What could it do? Or suppose I were to do this for the first 500, right? What could it do if memory were getting tight? Because it stores around away this information on how to compute it, what could it do? Well, it could throw away the data. And just as long as it remembers how to recompute it, you could always bring it back. Do you understand that? Yeah. Okay, so ladies and gentlemen, we have lifetime earnings for the Pop here. Okay. Now, we can do further things with this too. For example, we could reduce this value, right? How would we sum it up? Anyone say? So maybe I want to show this again. So maybe I'll do total lifetime earnings, or total lifetime earnings for young Pop. And I want to add these up. So I want to do it for each person, then I want to add them up. How would I add up? Remember, map, filter, and what's the missing one? Sum. Okay. Not actually. Sum, it won't. It actually won't. That's not part of its repertoire here. It is in other cases, but I could do reduce. Okay, now how do I tell it to reduce this to a single number? So this right now is a collection. How can I tell it to reduce it? I say reduce. What does reduce take as an argument? It takes a function. And what does that function do? It takes how many things? 2. And it produces how many things? 1. Okay, so what we'll do is we'll have a function that takes in 2 different numbers and adds them together. Do you see that? Do you see that? There it lies before you, right? And the young people have considerable wealth to their name. Well, lifetime earnings. Okay, and that approximation. So I just summed that up, right? Now let's take a look at that. Let's look at the to debug stream of that, right? Here we go. Ready? Boom. Oops, to debug. Oh, okay. I'm sorry. Okay. That's actually a double now. It's actually no longer a data set. So don't. You can leave the original in place there, and I will copy this to a new thing. Yeah, because it won't actually allow us to trace that all back. Okay. So this one still has that nice thing, But if we want to sum it up, we could do this entire thing, right? And we get back a double. Do you see that? Okay. So again, you should be feeling pretty comfortable with this. But in these notions of monads and accumulating information, like accumulating a lineage, how something is computed should be pretty familiar, right? Okay. I want to show a few more things, though, associated with this. So again, we're dealing with a data set we generate internally. Soon our attention will focus on data sets we bring in from outside, like from a CSV file. But in the meantime, let me just show you a few things. Population RDD dot, I'm going to say dot get num partitions. This is how many partitions is it dealing with? How many different sort of areas, each of which has processing units? How many partitions are there? Why 4?
It's on your local machine.
So on my local machine, this is purely local. It's actually a good guess, 4 fields, but it's actually something about my machine. 4 cores. It's because there are 4 cores. So when it performs a computation here, map, filter, reduce, it's tapping those 4 cores. It's dividing up the work to be done amongst those 4 cores. It's giving one core, hey, you map the first 250 elements. Second core, you map the second 250. Third core, you map the third 250. Fourth core, you map the fourth 250, the fourth quarter of them. And when it does filter, each of them will filter some of their components. Do you see what I mean? Okay, so those are those partitions. We could look more than that. I mean, these RDDs have actually a lot of additional types of information. We could say get storage level, sort of where's the specified level of storage that's been requested or used for this. And you could actually end up tailoring that in terms of essentially saying, hey, I want to really make an effort to store this in memory using something called persist, okay? And persist will say, hey, do your best to make sure that this RDD is kept in memory, for example, okay? Another thing that I could ask for example, would be the partitions, the details of the partitions. But it should be kind of familiar, but kind of foreign. I mean, there's some elements here that are very familiar, right? Map, reduce, filter, etc. There's some elements that are new in terms of these features, like the partitions and storage levels. And this is exactly my goal. It's to kind of avoid totally confusing you. But I'm going to do something different now. I am going to take this population, RDD, and I'm going to create a data frame. So now I'm going to look at data frames here. But again, for this built-in data, soon we'll be reading in it from disk. Okay, we're reading in it from a file. Are we ready? Okay, watch this. I'm going to say val df population. That stands for data frame. And we're going to say population RDD dot to df. Okay, to data frame. We ready with that? There we are. Now it created a data frame. It created one of these guys. Okay. Ladies and gentlemen, with that data frame, I can do some really powerful things. I can refer to columns. I can compute new columns. I can process one column, add it to a different column, get another column out, give it a new name, add it to my data set. All these sort of things, okay? These sort of things we're used to dealing with in R or Python, where we're kind of saying, hey, add the, multiply the income column by the age column as a whole. How would I do that? Well, it's a little bit different. Let's do some analogous things to what we've been doing, though, here. Watch this. DF population. Now we're working with the data frame, right? DF population dot filter, and I'm going to filter those whose age is less than 25. Now, you might think you could do this. Don't do it. Don't do it. Take my word for it, especially not at home, because it's going to be unhappy. It says, I don't know how to get an age from a row, because it doesn't know about age. It's not statically typed about this. What we instead have to do is do this, okay? So we have to do this, okay? This will allow us to get those whose age is less than 25. And if we do this, this is actually referring here to a column, okay? Alternatively, we could actually say, and this will refer to the, oops, it's not that. There are cases where you can do this. But here's, it's referring to a column. We're saying, give me all those who the value of their age for that row where looking in the age column is less than 25. Okay. Now let's see. Let's count the number. Let's count how many there are. All right. Here we go. There are. Now there was a pause. Why do you think it paused? It's doing now it's got to do all the calculations. It's got to convert it to a data frame because it hadn't done that yet. It just queued it up to do when you want it. So it's lazy, right? That's 229. We okay with that? Okay. So now let's filter the number whose sex. Let's find out the number whose sex is 1, or say females. How do we do that? Yeah. And in fact, we have to do triple equals. Okay? Because it's not just the Scala equals, it's the column equals. Okay? The sort of in terms of a column operation. Triple equals, okay? We'll count the number. They're 524. Okay? About half, which makes sense, right? Okay, now watch this. EF population dot filter, and you can copy this from up here. Okay. Dot group by sex. And what we'll see if we come out of that, ladies and gentlemen, is something called a relational grouped data set. Okay. Now, this is a special sort of construct. If we want to compute, for example, the average income for each of the sexes for those who are less than 25, we could say aggregate, and we'll say AVG $ income. And we could do this. And that's telling it, hey, compute the average income for each sex amongst those who are less than 25. But you'll notice it's not showing us the results. It's just a promise at this point. It's saying, okay, I'll do it when you want me to. Well, what if we want it to show? Okay, we could say show, okay? And here, ladies and gentlemen, it shows us. You notice it paused a little bit because it had to do the work. You see that? Your numbers may be a bit different than mine because of the random people involved. But here it's broken down by sex. What's the average income for that sex? Do you see that? Okay. Not bad. Okay, now let's take this one step further, okay? Watch this. You ready? Let's go to a data set. Now we're going to data sets, ladies and gentlemen. This sort of higher generation data sets. Do you see that? Okay. These data sets I claim are type safe. Is this guy type safe? This guy, like if we compiled some Scala code and it used this syntax, would that be type safe? No, because maybe I say this, right? When is it going to know that there's an error there?
Yes, sure.
When it actually runs it, when it actually tries to run it, it's going to say, oh, okay, X. Okay, I guess it's not case sensitive. See, it says there's no X, but it only noticed that when I ran it. Do you see that? So So, I'll say this is not type safe, right? The following error is only caught when executing. Do you see that? Okay, now watch this. Okay, go further than this. Let's go to a data set. This is type safe, the third generation, ladies and gentlemen. Brings in some ways the best of both worlds there. And optimizations like you get with data frames, but type safety, and actually extra optimizations, as I recall as well. Okay, so here we go. Val DS population, standing for data set, DS population, okay, equals population RDD.2DS, okay? Here it converted the RDD to a data set. Okay, now you might say that's a little bit of a cop-out because the RDD, it is type safe. I mean, it actually remembered, in that case, it knew the schema because we created it out of person. But let me show you how you can get this from a data frame, which is not type safe. So I alternatively could have said val DS population. We could do a DS population too. And I'm going to say it's DF population. That's a what? What is this guy? It refers to a data frame. Is that type safe? No. That's why this caused big problems, right? And only caught it when it actually runs. Ladies and gentlemen, I'm going to say dot as, and I'll say as person. Okay? What is this person thing? I'm saying render this as a type, as a strongly typed version, as a data set. You see, it gives back a data set of person. What is this person? Whence did that come? Who defined that? Yes, you defined it right up here. Remember, this is the case class, right? Remember that? The case class right here? That's where that came from. So case classes are really useful for telling if you have a data frame that you got from someplace and you want to treat it in a type safe way, in a way that knows the types of all the fields and so on. You can basically take that data frame and say as, and you give it the name of a case class, which shares the same names of the fields. And it will turn that into a data set. You basically tell it, use this schema, use this specification of what names there are in the data frame, and they are appropriately typed. And it knows how to take a case class and do that, okay? It knows how to say, oh, okay, this case class has a field called name that's a string, right? And so, this data frame, I bet it has a column called name, and yep, and here it is, and it has that's a string type, and because the case class has a sex that's an int in it, it'll say, okay, there's probably a sex column in this data frame, and it's going to be associated with an int. And so it gives it, this tells it the type information. Do you see my point? It tells it what the type is of each of the columns, and in fact, the names of the columns. Okay, so now we have a data set. And with this data set population, I'm not going to, because time is short and I want to get to importing a file, I'm not going to dwell on this for a long time, but we're going to be back in familiar territory for some of our sort of type safe ways of doing things in Scala. So for example, we can count the number of people who are less than 25 in age, right? Do you see that? Is that type safe? Yeah, it's type safe because it will actually check for us. It can check at compile time whether, you know, there's something called age that's a valid name for a field, right? I could say, for example, filter here dot sex, and I can just do equals 1 because this is a closure that's being operated. It doesn't have to be triple equals, just double equals, because it's not for a column here. It's actually, this is a closure that operates on each person. Do you see that? But there's limits, ladies and gentlemen. There's limits to how far we can go here. Okay. Well, maybe I'll show one thing more. I can take each person, filter it like that, and I can map, and maybe I'll divide their income by 10.0 or something like that, right? Something along those lines. And this will yield me another data set of doubles, and I could reduce it by adding things together, right? Oops. So this will be, now it's called value, which is called this value here. And I will add this. I'm sorry. What am I doing? No, it's just going to be this. Yeah. Boom. That should work. Oh, okay. We okay? So now we're operating a type safe territory again for the same basic data set. Are we okay with that? Okay. Next, ladies and gentlemen, we are going to read in a file from a CSV file, and we are going to manipulate it in similar ways, okay? So time is of the essence. I need you to follow the following carefully, and it's conceivable that some of you will encounter challenges with this, in which case you can just follow along, okay? Because it requires typing things very carefully. I am going to download, okay, here's the deal. Spark needs, if you want to load a file in Spark, it's going to need to be available on every machine where Spark is running, like that you'll be counting on. So if you wanted to use all those machines out there in the lab, each of them, and you want to process a file, each of them has to be able to get to that file. So one way to accomplish this is to add the file to each machine that needs it. So I'm going to specify a file to add from a URL. Okay, here we go. See this? HTTPS. Be sure to do the S. This was causing me problems about midnight last night. Actually, there are two things. First, I needed the www in front, because if you go to it without it to the web page, I think it redirects you automatically. And with the www now, okay, that's needed. And then secondly, it has to be HTTPS. Normally, it will just automatically go from the web browser, just automatically goes, but you need it here, okay? www.cs.ustass.ca/faculty/osgood/cchs.csv. Make sure that it's all capitalized in that way, okay? CCHS capitalized. Okay, watch this. So add that file. Boom. Okay. Now, so that's going to be ready when it needs it, okay? Now, watch this. Val df cchs equals spark dot read dot format quote CSV dot option header comma true. Oops, there's only quotes around header. Yeah. Dot option infer schema, where schema has the first letter capitalized, comma true. What are these things that I'm specifying here? It's kind of a fluent style of specifying what? Options, ladies and gentlemen, options. Dot load. So with those options, like, hey, yeah, go ahead and infer the schema. Go ahead and infer the types. Figure out the header. You know, recognize there's a header to give the names. dot load, and now, and I'm sorry for the long thing here, org.apache.spark.sparkfiles.get, and we need to find out where that CCHS file went. Okay, where did it go? This is, and then there's, I think, 2 end parens here. Okay, so what do? We loaded this. We told it, hey, you're going to be loading up this file onto each place where this is executing, and then for each machine, it's going to get the location where that file went, and it's going to load a CSV from that place, inferring the schema to figure out the types, and getting the headers to get the names of the fields, and it's a CSV. Do you see that? Okay. So time is of the essence, and so I'm just going to run this. And there it is. What do you think this is? What do you see here?
Number of fields.
Yeah, and what are these things? Yeah, these are the names of the fields. Like that's geographic province. This, by the way, is the Canadian Community Health Survey. Okay, so let's take a look here. DF CCHS, and I'm going to say print schema. Print schema. Okay, here we go. Look at that. Look at that. It's print out a schema there. Okay. I think this is actually a subset of it. Although no, it says there's 133 more fields. Yes, it's a subset of it. I think I did. Okay, next. dfcchs.count. What do you think this is going to give? The number of rows, actually, in this case, 93,000. Okay. Next. Okay. Now what we're going to do is we're going to count the number of people whose BMI is greater than 30. Now, what am I dealing with here? This is a data frame. So does it know? Does it statically know? Like if I typed, p.age or something, would it know how to do that? No. So we have to refer to the fields, ladies and gentlemen. So here what we'll do is we'll say df cchs.filter, and we have to refer to a field, right? So I'm going to refer to a column here. Height. This is actually, sorry. This is ultimately BMI. It's HWTEG BMI. I think that's HWTE is probably sort of the height and weight sort of section of it or something like that. BMI, and I'm going to say dot count. Oops, dot count. Okay, sorry, what am I doing? Greater than 30. Okay, that's an obesity cutoff, and I'm going to say, okay, how many individuals? 16,408 rows. Are we okay with that? Mm-hmm. Okay. Okay. Next, I am going to, and this will be in the interest of time and giving you things and the need to coordinate. What I'm going to do is I'm going to say val, I'm watching the time here, df cchs selected. I'm going to select a few columns. So it's going to be df cchs.select. I'm going to select some columns. In other words, I'm going to grab some columns out of it, okay? And the columns I'm going to grab out are going to be called geo EGPRV. I think that's the geographic province. GeoEGPRV. Yeah. That same one we used above. Height, weight, BMI. Notice we're referring to all these things. Okay. Next, the DHHE So this is the age. Next, the HHE sex. Okay? These are selected ones. By the way, does this remind you of something? Select? Does that sound like a certain language, which many of you know? SQL. And in fact, Spark has excellent support for SQL type operations. So here I've selected those fields. Do you see that? I've selected 4 fields. Now, and what I'm going to do is I'm going to say case class, and I'm going to say CCHS subset schema. And guess what are going to be the names of those fields? Yeah, same thing. So this is going to be an int. This guy, oops, int with a capital I. This guy is going to be is going to be a double. You can see it here. This guy is going to be an int, and the last one is going to be an int. Okay. Okay. There we go. Are we ready for that? There we go. Boom. There we go. Okay. Now, having a case class, what can we do now? We have a case class. What does that allow us to do? Well, it allows us to create a typed manipulation of this. So now we could say df, ds, CCHS selected, and it's equal to df selected dot what? Dot as, and guess what goes in the as? This schema. So all we've done is we've taken as a data frame a subset of this data frame, the entire data frame. So only certain columns. We've defined a schema for it using a case class, and we've said, hey, render this data frame using this case class as a data set. Do you see that? Okay, now watch this. Boom. Boom. Do you see that? Maybe yours doesn't make that sound, but it's still probably hopefully working. Okay. Okay, so here we go. DS, and we'll just engage in some frobbing behavior if that's okay. So watch this. Dot filter, and we'll say dot DHHE sex equals 1 dot count. Okay. What is this going to be doing? What is that going to be doing? It's going to count the number of, I can't remember, number of rows for which the sex is 1. Yeah, maybe male, maybe female, I can't remember. Alternatively, we could do it for 2 and count the number of rows of that, right? Similarly, we could do something like count the number for a given sex. So let's just do this. This will be amongst the very last things we're doing here. We're going to count the number who have sex 2, count the number of people of different age groups or different ages. So I'm going to say this, and then what would I do? If I want to count the number who have different ages, what would I need to do? Group by, and I need to group by a name of a column, unfortunately. It requires you to say the name of a column, DHS gauge, okay, which is age, okay? Those basic demographics, I think. And then I'm going to say aggregate count of, and the final field is GOEGPRV. In case you didn't notice, I did not give these names. These were handed to me with reluctance. Maybe they want to keep it short. Okay. So suppose there's a video of me on YouTube. There's a sort of video about my naming style. It has me engaged in interactions with 100-character names or something. Some of my students put it together, I think. Okay, so there we go. Okay. I must have misspelled DHH E, not S. Yeah. Hold on, students. Okay, there we go. So, and then what do we need to do to show it? Show. There we go. Okay, ladies and gentlemen, here we go. What is this doing? By the way, notice it's performance income. What is this doing? Can you describe at a high level, what is that computing? The count of people who are of different ages amongst those who have sex too, right? And similarly, we could do it for sex one, right? Alternatively, I believe, and I'm going to go out on a limb here, but I believe you could do this. Let's get rid of that filter, and let's do group by that and by sex. Okay, DHHE sex, DHHE underbar sex. And we're going to count the number in each bin. There we are. See, this is a count of the number who are of sex to age 10. This is the number. By the way, I'm just counting. This is how I'm counting the number. It's counting the number that have this field. And, you know, so for age, you know, each of the age categories, there will be several different things. And it's only showing me a fragment of this, but I could probably tell it to show a more complete one. So for example, the count of those who are 7 years old and sex 1 is this, the count 7 in sex 2 is this guy. Do you see that? Okay. The final thing I will just note here, and this will be my final element, is once you have that, you could then also so we did this with data sets and data frames, but we could also convert back and operate in terms of an RDD. Okay, if we wanted to use the basic RDD interface, we could get that from data sets or data frames and basically manipulate it using RDD APIs, much as we did way back when we were dealing with this population RDD. Okay, so these are 3 different ways of manipulating collection data within Scala. Data resilient distributed data sets, data frames, and data sets. Okay, and each of them offers benefits. Data sets are more recent. These are successive generations, but each you can make use of the others. And there's some operations, like reading a CSV file, that only yield some of these. Like data frame is what's yielded by reading a CSV file. So when we read a CSV file, we couldn't directly say, hey, read it in as a data set right now. Instead, we needed to read it in as a data frame. That's what came out of this load. And then we could convert that to an RDD if we wanted to, or to a data frame, okay? Or to a data set, rather, with this type of information. That's why we defined the case class to turn it into a data set, okay? That's all we have time for today. Thank you for your attention. And I'm glad we had better video today. And now I will stop the broadcast. Okay. Thanks very much.